Hi, this is Dr. Shoykat Mujumdar. Under Basic Physics course in Diploma Engineering, we will discuss Photoelectric Effect. Photoelectric effect falls under modern physics of Unit 5 of State Council syllabus. The learning objective is to study and understand the effect of intensity and frequency of a light wave on the photoelectrons and quantitative study of the equations, work function and threshold frequency. Now, to start with, let us discuss particle nature of radiation. Radiation of energy is usually characterized by its wave-like nature. But many experimental observations such as black body radiation, photoelectric effect, Compton effect, pair production, etc. cannot be explained properly only by considering the wave nature of radiation. This phenomena, along with any natural phenomena from elementary particle level to the cosmological level, can be properly explained on the basis of particle aspect of radiation, that is, the quantum theory of radiation. In that case, the wave of electromagnetic radiation behave like particles of definite momentum and energy. Now, to start with, the basic informations that we have to learn. The conductor, it has large number of free electrons. Similarly, the metal contains a large number of free electrons which move arbitrarily inside the metal due to thermal energy at room temperature, but they cannot come out of the metal because of the surface barrier energy. If sufficient energy is supplied to those electrons, they can come out of the metal and emission of electrons is said to take place. Different types of emission of electrons from metal are as follows. Number 1, thermionic emission. Here, electrons are emitted from metal by supplying suitable thermal energy or heat energy. Photoelectric emission. Emission of electrons from metal take place with the help of suitable energy. that is suitable light energy exactly. Field emission, electrons are taken out of the metal by applying suitable electric field. Here in photoelectric effect, emission of electrons from metal take place with the help of suitable light energy. In thermionic emission, suitable thermal energy or heat energy. Field emission by applying suitable electric field. And final and fourth one is secondary emission. Electrons can also be emitted from a metal by hitting them with a stream of energetic electrons. So, by hitting stream of energetic electrons, electrons also be emitted from the metal surface. This is the secondary emission. Using electrons, we are getting the electrons or emission of electrons. Photoelectric effect. It has been determined experimentally that when light shines on a metal surface, the surface emits electrons. This is the metal surface where there are free electrons. So when light in the form of photon is falling onto it, electrons are liberated from the metal surface. If we prepare a circuit using ammeter and voltmeter, we will get a current here. So a flow of current is in a circuit just by shining a light on a metal plate. That means we will get a flow of current in circuit when the metal plate is shining by light. So here, this is a schematic diagram to produce photoelectrons. This is a plate P and here is the cathode. Plate P is connected to the negative terminal of this one. Sorry, this is not cathode, this is C. C is the collector. C is the collector, P is the plate. C is the collector, P is the plate. C is connected to the positive terminal of the battery, P is connected to the negative terminal of the battery. Now ammeter is connected in series. This is placed in an evacuated chamber. Now when light source is falling onto this, then of suitable frequency, definitely suitable frequency, when light source is falling with suitable frequency, electrons are liberated. These electrons are liberated from the light source. These electrons are liberated and they are collected by the collector. As it is positive terminal, it is collected by terminal. So there is a current in the circuit. A metal plate P and a small electrode C are placed inside an evacuated glass. This is known as a photocell. Two electrodes are connected to an ammeter and a source of EMF. When the photocell is in dark, that means no light is falling onto it, ammeter reads 0. That means I is equal to 0 ampere. When light of sufficiently high frequency illuminates the plate, the ammeter indicates the current flowing in the circuit. Now enjoy a video that is taken from YouTube. Acknowledgement is shared here. So how this photoelectric effect is going on, or how it happens is let us discuss this one first. Look, this is the evacuated glass tube. This electrode is connected to the negative terminal and this electrode is connected to the positive terminal. Now, this is cathode, negative terminal, this is anode. This is the ammeter. Light in the form of photon is made to fall on the cathode. That means this surface is shining by light. Then electrons will liberate and it will be attracted by the positive terminal of the electrode. These electrons are coming out and these are attracted by this terminal. Then there is a flow of current. Flow of electron, that means there is a current. We will get a deflection in the ammeter. So this video describes the photoelectric effect very well. Now there are a few definitions. First one is photoelectric effect. When light radiation of suitable frequency be incident on a metal surface, electrons are emitted from the metal. This phenomenon is known as photoelectric effect. If the photoelectrons be placed under a potential difference, they will move towards the positive terminal, thereby constituting a current known as photoelectric current. So when the electrons are moving towards the positive terminal under the potential difference, they will constitute a current. This current is known as photoelectric current. The number of photoelectrons emitted per unit time from a given substance depends on, number one, the intensity of radiation, and number two, the surface area of the material exposed to the radiation. Now, if we try to explain this with the wave theory predictions are like this. If the light intensity increase, the number of electrons ejected and the maximum kinetic energy increase. As per wave theory, if we increase the intensity of light, the number of electrons, ejection of number of electrons will increase, and increase in kinetic energy will also happen, because the higher intensity means a greater electric field amplitude, and the greater electric field should eject electrons with higher speed. This is as per wave theory predictions. I am not going to teach, I am not going to tell right now which one is correct, which one is incorrect. But here wave theory predictions is like this. And the wave theory also predicts the frequency of light does not affect the kinetic energy of the ejected electrons. Remember, as per wave theory, kinetic energy will not be hampered by the frequency of incident light. Now come to this part. Now in reverse bias, what will happen? Here the plate is connected with the positive terminal. Initially in forward bias, the plate was connected with the negative terminal. Here there is the collector. Collector is connected with the negative terminal in this reverse bias condition. Now light of suitable frequency is falling onto this. This all, everything is kept in an evacuated quartz tube. So the emission of electrons from a metal plate when illuminated by light or any other radiation of wavelength or frequency is called photoelectric effect, and emitted electrons are called photoelectrons. Now, if lights of higher wavelengths, that means frequency is less, mid to fall, then we can see there may be no emission of electrons. That means there is, in the circuit there is no photoelectric current. Again, if the light of suitable frequency, that means say the frequency is high, is falling onto the metal surface, that means a violet light, its wavelength is less, its frequency is high, then electrons are liberated, and the metal surface is say sodium or potassium coated metal surface. Electrons are liberated and we are getting photoelectric current instantaneously. If we increase the potential here, then the negativity of the collecting plate will increase. So increasing the negativity of the collecting plate, it will bar the electrons coming from the metal plate to the collecting plate. That means it will stop its motion, sufficient increasing of the potential. So for slow increase in potential, what will happen? The number of electrons coming from the metal surface to the collecting plate becomes less. So for a particular applied potential, what will happen? These electrons will not liberate. That will be, all the electrons will be here. Why it is not liberated? It is not liberating. Actually, it is negatively charged, and this one is, electron is also negatively charged. So it is stopping its movement or its acceleration. Then what is happening? It is just on the metal surface for a particular voltage. That means it looks like the electrons are just waiting on the surface and they are ready to get energy and to move, but it is obstructed by the negativity of the collecting plate. So the potential for which the electron are just on the metal surface, that means there is no liberation of electron, is known as stopping potential. Now, if we increase the intensity of light, when the electrons are moving from metal plate to the collecting plate and we are getting the current in the circuit, if we increase the light, already we have discussed, if we increase the intensity of light, then the intensity of the current will increase. Current will increase. But liberation of photoelectrons is depending upon a particular frequency. If the frequency is less, then energy of incident light will be less. Energy less means less amount of energy is supplied to the metal surface, to the electrons, metal surface as well as to the electrons. So it is not getting the sufficient amount of energy. That's why it cannot be liberated from the metal surface, and after that the kinetic energy is not sufficient. So it is not coming from metal plate to this. If the energy of the light is less, that means frequency of the light, incident light is less. If frequency is increasing, means energy increasing. Energy increasing means some amount of energy is absorbed by the electrons to reach to the metal surface, and excess of that energy, it will be supplied as a kinetic energy. And using this kinetic energy, these electrons will move from the metal plate to the collecting plate, and we will get the photoelectric current. The frequency for which electrons are just on the metal surface, there is no kinetic energy of the electrons, this frequency is known as the threshold frequency.